Astronomers have just made a discovery that's rewriting the timeline of cosmic evolution. Two independent teams of researchers have detected oxygen in the most distant known galaxy, JADE's GSZ 14-0, using the Atacama Large Millimeter/Submillimeter Array, or ALMA, in Chile's Atacama Desert. The galaxy itself was initially spotted by the James Webb Space Telescope last year, but it took ALMA's incredible sensitivity to confirm its distance and detect oxygen within it. In this video, we will explore this groundbreaking discovery, examine its implications for galaxy evolution, and discuss how it might change our understanding of the potential for early life in the cosmos. The galaxy JADE's GSZ 14-0 holds the record as the most distant confirmed galaxy ever observed, situated in the Fornax constellation. What makes this discovery truly extraordinary is the journey its light has taken to reach us. The photons captured by our telescopes left this galaxy 13.4 billion years ago, traveling through the expanding fabric of space-time before finally reaching Earth. This means we're seeing this galaxy not as it is today, but as it existed when the universe was in its infancy, less than 300 million years after the Big Bang, which occurred approximately 13.8 billion years ago. The detection of oxygen in this ancient galaxy required the combined power of two cutting-edge astronomical instruments. The James Webb Space Telescope, Webb, first identified the galaxy through its infrared capabilities, which can peer through cosmic dust and detect light that has been stretched by the expansion of the universe. However, it was ALMA that made the crucial oxygen detection. ALMA consists of 66 high-precision antennas spread across the Atacama Desert in Chile, working together as a single telescope. This array operates in the millimeter and submillimeter wavelengths, which are ideal for detecting the emissions from elements like oxygen in distant galaxies. What's particularly impressive about ALMA's detection is the unprecedented precision of the distance measurement. As Eleonora Parlanti, a PhD student at the Scuola Normale Superiore of Pisa and co-author of one of the studies, explains, the ALMA detection offers an extraordinarily precise measurement of the galaxy's distance down to an uncertainty of just 0.005%. To appreciate this level of precision, it's comparable to measuring a distance of 1 kilometer with an accuracy of just 5 centimeters. Such precision is crucial for understanding the properties of distant galaxies and placing them correctly in the timeline of cosmic evolution. The detection of oxygen itself came as a surprise to researchers. Oxygen is what astronomers call a heavy element, anything heavier than hydrogen and helium, which were the only elements formed in significant quantities during the Big Bang. All other elements, including oxygen, are primarily created through nuclear fusion inside stars and then dispersed throughout galaxies when massive stars explode as supernovae. This process takes time, which is why finding substantial oxygen in such an early galaxy has astronomers rethinking their models. The two teams that made this discovery, one led by Stefano Carniani from Italy and the other by Sander Schouws from the Netherlands, published their findings in separate papers in the prestigious journals Astronomy and Astrophysics and the Astrophysical Journal, respectively. Both teams independently confirmed the presence of oxygen using different analytical approaches, strengthening the reliability of this groundbreaking result. The technical achievement behind this detection cannot be overstated. Observing a galaxy at this distance is already challenging, but detecting specific elements within it pushes the boundaries of our technological capabilities. The light from this galaxy is not only incredibly faint after its 13.4 billion year journey, but has also been significantly redshifted, stretched to longer wavelengths by the expansion of the universe. ALMA's ability to detect the specific emission lines of oxygen atoms, which have been shifted from their original wavelengths, demonstrates the remarkable sensitivity of modern astronomical instruments, This discovery exemplifies the power of complementary observatories working in concert. As Associate Professor Richard Bowens from Leiden Observatory notes, this shows the amazing synergy between ALMA and Webb to reveal the formation and evolution of the first galaxies. The detection of oxygen in JADE's GS Z14-0 has profound implications for our understanding of galaxy evolution. Traditional models of galaxy formation posited that the earliest galaxies should be chemically pristine, composed almost entirely of hydrogen and helium, the elements forged in the Big Bang. Heavier elements like oxygen were thought to accumulate gradually over billions of years, as successive generations of stars lived and died. However, this new discovery reveals a galaxy that is chemically mature far earlier than expected, containing approximately 10 times more heavy elements than current models predicted. Sander Schouws, the lead author of the Dutch-led study, describes this surprising find as finding an adolescent where you would only expect babies. Astronomers expected to find only nascent, chemically simple galaxies in the early universe, but instead discovered one that had already undergone significant chemical evolution, a cosmic teenager in a nursery of infants. This unexpected chemical maturity raises fundamental questions about the mechanisms of early galaxy formation. For oxygen to be present in such quantities, several generations of massive stars must have already lived and died within this galaxy, enriching their surroundings with the products of stellar nucleosynthesis. This process was thought to take billions of years, not the mere 300 million years that had elapsed since the Big Bang when we observed this galaxy. Stefano Carniani, who led the Italian team, emphasizes the paradigm-shifting nature of this discovery. The evidence that a galaxy is already mature in the infant universe raises questions about when and how galaxies formed. These questions now demand new theoretical frameworks that can account for much faster rates of star formation and chemical enrichment than previously considered possible. One possibility is that star formation in the early universe proceeded much more efficiently than in later epochs. The first stars, known as population 3 stars, are thought to have been exceptionally massive, perhaps hundreds of times the mass of our Sun. Such stars would have burned through their nuclear fuel rapidly, perhaps living only a few million years before exploding as supernovae and releasing newly synthesized heavy elements into their surroundings. If these early stellar populations were particularly top-heavy, dominated by massive stars rather than smaller ones like our Sun, they could have accelerated the chemical enrichment of their host galaxies. Another possibility is that the very first galaxies formed earlier than current models suggest, perhaps as early as 100 million years after the Big Bang. This would have given them more time to evolve chemically before we observed them. Alternatively, galaxy mergers in the early universe might have played a more significant role than expected, combining the chemical inventories of multiple young galaxies and accelerating the process of enrichment. The abundance of oxygen specifically is noteworthy because oxygen is one of the most abundant heavy elements in the universe today and plays a crucial role in the chemistry of galaxies. It forms through nuclear fusion in the cores of massive stars and is released when these stars explode. Webb will continue identifying candidate early galaxies, while planned upgrades to ALMA will enhance its sensitivity, potentially allowing for the detection of additional elements beyond oxygen in these distant objects. Facilities like the Square Kilometre Array and the Extremely Large Telescope will provide complementary data at different wavelengths, offering a more complete picture of these early cosmic structures. Beyond simply confirming this discovery in other galaxies, astronomers are revising theoretical models to account for this accelerated timeline of galaxy evolution. New simulations are being developed that incorporate different star formation rates, altered initial mass functions, the distribution of stellar masses when stars form, and novel mechanisms for mixing and dispersing heavy elements throughout primordial galaxies. These revised models will generate predictions that can be tested against future observations, creating a feedback loop that progressively refines our understanding. One of the most intriguing implications of this discovery relates to the potential for early habitability in the universe. Oxygen is not only important for galaxy evolution, but is also a key element for life as we know it on Earth. The finding that oxygen and other heavy elements formed much earlier than expected suggests that the ingredients necessary for planetary formation and potentially for life might have been available much sooner in cosmic history than previously thought. While the oxygen detected in JWST's 14-0 is in gaseous form within the interstellar medium, not the molecular oxygen we breathe, its presence indicates that the chemical prerequisites for rocky planets could have existed in the very early universe. If planets could form earlier, the timeline for the potential emergence of life throughout the cosmos might need reconsideration. As astronomers continue to push the boundaries of observable distance and time, they inch closer to answering one of humanity's most profound questions: how common might life be in our universe? Perhaps most significantly, this finding reminds us that the universe continues to surprise us. As Stefano Carniani notes, the detection opened a new view on the first phases of galaxy evolution. Each time we push the boundaries of our observational capabilities, we encounter phenomena that challenge our existing frameworks and force us to reimagine cosmic history. Thank you for watching this exploration of one of astronomy's most exciting recent discoveries. If you enjoyed learning about the oxygen detection in the most distant known galaxy, please like this video and subscribe for more cosmic revelations. Until next time, keep looking up and wondering about the magnificent universe we're privileged to explore.